it's not hard anymore, but if I sit for a
Mine
while
too.
and think about
Ron told me to change that.
I saw it
Yes,
erased, so I had to rewrite it again.
Not as much as I want to because I'm a player. Yeah, but it's
Oh,
okay.
can you scoot over a little bit?
All right, if you did watch the video from yesterday, which I'm sure most of you didn't, I did finish these other two on there. I said I was going to do up through 5, and I did put them on there. Number 4, if you watch number 4, as I do it now, this is going to be, what we're going to do today is going to go right along with this. So I'm actually going to show you, since this one works out all right, I'm going to show you like 2 different ways that you could do this problem. Please, I almost hate showing most people 2 different ways to do the same problem, because then what happens? Then they get mixed up and
They
they
do them both.
do them both at the same time and you get it all. What you could do, and what I did on the video, was I split off the small triangle, the big triangle, and then to find, let's see, in this small triangle, this is 6x plus 2. In the small triangle, how long is this part, this bottom right here? 16. You'd have to subtract there, right? And the big, let's make it a triangle since I messed up.
24.
This one's 24. And the big
7x
triangle,
plus
7x plus 7.
I got that far, that's all.
Now you set up your proportion, and I'm just going to set it up, then I'm going to solve it the other way because the other way is easier. What matches up? Give me 2 sides that match up. 24 and 16.
Now, what if you like set it proportional to like its own triangle, like 6x plus 2 is to 16 instead of x plus 7?
Okay, you could do that. So I always go from one triangle to the other, so I make sure I know which sides
Well,
match
some
up.
of them, I don't think in this homework, I think we had to set them.
You never have to, because you always have to have 4 parts. So you could do it either way, either time. So if you wanted to, I'd set this one up this way. We did the 24, so this has to be 7x plus 7 over 6x plus 2. And what you're saying, Peyton, is that you could have set up 6x plus 2 over 16, and then 7x plus 7 over 24. I don't do it that way because when I do it that way, I forget maybe which way I went, and so I get confused. So if I start with this triangle, go that way, then I know to come back over here, start with that triangle again, and go that way. That way it makes it easier on me. However's easiest for you. Now what I would do, we know that this part right here is 16, you guys have already told me that. One of the theorems that we're going to cover today says if you have some segment that runs through a triangle and it's parallel to one of the sides of the triangle, instead of going through and adding all these together and subtracting and doing all that, this, and this would go along with what you're saying, Peyton, this has to compare to that the same as this compares to that. So you can just set up your ratios from here and here. So x plus 5 over 6x plus 2. And that's going to equal, what's the other one going to be? 8 to 16. We're going to learn that theorem today. It's just another rule that works out. And it makes it easier when you have something like this picture. Now, when we have this picture where these 2 are parallel, that new theorem's not always going to work, because sometimes they might tell you that this part right in here is 7. Well, you can't. You got to split off the triangles in. So you could do it either way. Sometimes it's easier to do it this way, like on this one especially. What's 8 over 16 reduced to? So when I put parentheses around this stuff, what's 1 times all of this? That's pretty easy, right? And then 2 times all this, 2x plus 10. Subtract 2x on both sides. 4x plus 2, put it in right, equals 10, subtract 2, 4x equals 8, x equals 2, what'd they ask us to find?
So NL and ML.
So NL, let's see, where's NL? That's this whole thing, right? And then ML is just this part. Let's find this part first. What's ML? 6 times 2 is what?
14.
If you look back over here, what was that ratio? What do you think in it? This part up here is going to be then? Should be 7, that's 14. And what's NL, the whole thing? 21. Anybody get that when they worked it out?
What?
It's 14 and 21.
I could have. That's
So,
what I skipped.
even doing it, you know, if you did it the way that we did it last time, it's still gonna work out the same. Again, this is a new theorem that we're gonna introduce today, where this compares to this, the same as this compares to this. And we don't have to split off the triangles and do all that addition and subtraction, remember to do all that. So, sometimes it's easier one way, sometimes it's easier the other, it just depends on the problem.
Well, I kind of gave up.
Yeah, me too.
I wouldn't hold it against you if you couldn't, because you know, it's sort of a harder problem. I don't expect people like Austin and Corbin and Faith to be able to figure it out. Right.
Wow, I'm not even considered a smart kid.
Daggone, I was recording that again. That'd get me in trouble.
You know, I got a 93 in my exam.
Has anybody ever said that you weren't intelligent?
My mom.
You just did.
Nick maybe. I've never ever said it. Because you are very intelligent. You just
Make bad decisions.
don't apply yourself very often.
What's that supposed to mean?
All right, we have the same setup as that last triangle, but this time we don't know this part over here. So you can't just say this compares to this, same as this compares to this, so that won't help us. What we can do here though is split off the two triangles. You got your small triangle, you got your big triangle. This side is 6, that side's 12.
Wait, I have a question.
Yep.
Since those are parallel
Mhm.
and 9 of the same sides, wouldn't
Stop
x
yourself while you're
plus
doing
5
It would be if it was the other way. If this 9 was down here and x plus 5 was up there, and that's another theorem that we're going to learn today. So if these two were the same and these two, then these two would have to be the same if these are parallel, but it doesn't work across this way. Because your triangle could look like this, you know, don't go by my drawing. Your triangle could look like that, and you have these in here parallel, and this is 9, this is 9. Well, are these two going to be the same? So if it was, like I said, if it was this was 9 and this was 9, where this was a midpoint right here, and x plus 5 was up here, this would have to be x plus 5 also. But it doesn't work the other way around. How long is this side in the big triangle?
9. Oh,
X plus 14, right? What's our proportion going to be? What matches up to what? 6 over 12. Now I'm not even going to write down 6 over 12. That reduces to 1/2. Then what's the other one going to be?
2x. No.
X plus 5.
And
X plus 14. Makes it a lot easier because when we cross multiply here, what's 1 times all that? So if you reduce them, if you can, it makes it easier. What's that going to give us when we multiply the means there? 2x plus 10. Subtract x. What's x equal? 4.
So they are equal.
Are they equal?
Yeah.
Uh, So if that's 4, that means this part is 9. Well, if that's 9, guess what this part up here's got to be?
9.
Math,
That
rule
was
of
one of our questions. It asked for what? E8?
Where is Bill 9? 9.
Anybody, this segment right here, this segment through here, this is part of what we're going to cover today. It's called something special. Anybody have a guess? Math people are real creative about stuff like this.
Intraline.
What's it connect?
Sideline.
So think of the name.
Connects the midpoints, doesn't it? Guess what it's called?
Midpoint
segment.
It's a mid segment.
That's so
Wow, that is
stupid.
so creative.
That's what I said. Math people always real creative like that. Connects the midpoints. It's a segment, so it's called the mid segment.
Your parents don't text?
Oh,
That's probably the first time I called it out.
Alright,
When we did bring back that other paper. Yeah, I called.
Called me before.
Let's see, what if Josh answers the phone?
She's not home usually when I call.
I was on one time with my dad.
He said he was gonna call you. He's gonna be out.
My dad's
Is this your home? True.
All right, write this down. Again, we don't have much time, so we're going to go through this sort of quickly. What we're covering, we're going to go, still setting up proportions. We're going to go over 3 other theorems, different ways to set up proportions involving triangles and parallel lines and different ideas.
Are we doing number 8 on the 310 part, like in this
Yeah.
section?
Yeah, sort of.
That's what I always do. Well, that's what it's meant for, because my desk isn't big enough to handle it. That's why you get 2 desks. That's why you get 2 desks. Right. Just, okay.
Don't make me get the grapes.
This is the first theorem, triangle proportionality theorem. This is the one that we talked about with that other problem. Now I'm just going to write a proportion for each of these. This triangle proportionality theorem says if you have some segment, and you notice this black segment's a little darker. If you have some segment that goes through the triangle and it's parallel to one of the sides of the triangle, then segment AB, that's right here, compared to segment BC, which is right there, is always going to be the same ratio as segment AD, which is here. I put like a smiley face, compared to segment DE, which is right here. Now that doesn't mean that the smiley faces have to be the same. All we're saying is this over this equals this segment over that segment. So you don't have to split off the triangles. That's what we were talking about a few minutes ago. Now that only works if these two are parallel to each other, which a lot of times they will be, otherwise you won't have similar triangles anyway and we wouldn't be doing all this. Now, if you don't remember this theorem, and they told you something like this is 5, this is 8, this is x plus 2, this is x minus 3, could you go back and split off the two triangles?
Yeah.
And do 5 compares to 13, the same as x plus 2 compares to, add those two together and get 2x minus 1. Yeah, you could do the same thing, splitting off the triangles. So use this theorem if it's helpful. Sometimes, if you're not sure, then go back to using the small triangle compared to the big triangle and splitting the two off.
But that's only when you have like all
Right. And so if you know like one of these parts, if they tell you that part down there is 10 or something, then you have to use the triangles. Because these two, the two parallel ones, don't really have anything to do with the proportionality except that they have to be parallel to each other. So they help you to know that you can use that other theorem, but if you know the lengths of those sides, it doesn't help you to set up a proportion. That makes sense. And if it, again, if you're confused, split off the triangles all the time and it'll always work that way. A mid-segment, this is the actual definition of a mid-segment. And one of the creative names math people give different things. Yeah, 6.6. If that point right there is a midpoint, what do you know about these two segments?
2 equal.
All right, so those two are equal. If that point's a midpoint, what do you know about those two segments? Now, it doesn't have to be where all four of them are equal. It could be, but the two on the left side have to be congruent, and the two on the right side have to be congruent. That makes this one right here in the middle, that's called a mid-segment then. There's two things that are true about a mid-segment. If you know that that segment is a mid-segment, the first thing is the mid-segment is parallel to the third side. So that mid-segment has to be parallel to that third side. Well, as soon as they're parallel, then we can jump back to the other theorem, and we know that this compares to this, the same as this compares to this, and you can set up those proportions. So if that's a mid-segment, then you can also use that theorem that we just got done talking about before this one. This is the one the second one's the one I really want you to remember, because this is the one, guarantee I throw about 3 or 4 of these on the next test, because I like putting stuff like this on there where you got to read a paragraph and then your answer is real simple.
Yeah.
You like those?
Yeah, because it always, I get a good laugh when everybody's looking at it and they write down 60 million things, and then all they had to do was actually divide and come up with the answer, and they didn't have to do all that. So the mid-segment is half the length of the third side. So on the test, I put something like this. This is x plus 9. This is 3x minus 4. This is 5y plus 2. This is 3y minus 8. This part right down here is 12. And I would ask you to find the length of that mid-segment. So how long is that mid-segment? 6. You didn't need any of this information at all. This mid-segment has to be half as long as that third side. Or if we did it the other way, this was a mid-segment, and we knew that the mid-segment was 7 units long, how long would this third side have to be? 14.
Now on those, will it say without line as a mid-segment?
Well, it'll either tell you it's a mid-segment or
So,
shows it with the tick marks. So for this to be a mid-segment, all that has to be true is that's a midpoint, that's a midpoint. So I could even write out a statement like, we'll call that A, call that B. I could say points A and B are midpoints. Then from there you should be able to decide it's a mid-segment. 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So as you're writing this down, all they're saying is if these lines are parallel, you could have 4, 5, 6, 7, 8 parallel lines. If those lines are parallel to each other, then the way they cut these transversals going down through here, the parts have to be proportional with each other. And this is one, Peyton said something earlier about, matching it up differently. This is one where when you match these up, it's completely up to you which way you match them up, because it'll work both ways, and I can understand, neither one seems easier or harder than the other one. If I put some letters in here, I'm going to call that little segment right there A, this part B, this part C, that part D. Let me erase that.
Linda's using her black magic. Speeding everything
So all that's saying, if these are parallel, then I know that A compares to B, this part compares to this part, that whole segment there, the same as C compares to D. So that part compares to that part. And there, I like to do it this way, these two to each other, those two to each other, because I can just draw that in there and set up the proportion, and that's how it's going to be set up. Now, if you wanted to write it a different way, what's a different way that could be set up?
B over A.
Yeah, that's true. Flip it over, right? Give me a different one than that. A compares to C, the same as B to D. So you could go that way if you wanted. You could flip them over if you wanted. You could go starting over here and going this way, and it's still all going to come out the same. Now, the things you can't do, you can't compare like A and D, B and C, cross corners and all that. It's got to match up somehow. I'm not sure why I wrote down page, yeah, I am sure why. I wrote down page 311 to 315.
Just to make it sound long.
No, because somebody must have said, well, the only problems on 311 are problems 6, 7, and 8. And I had to explain to them, all right, if the assignment starts on 311, it's got to go on 2 other pages
Oh, sweet.
many times.
Are you collecting these?
The worksheets.
No. Here's a missing assignment.
The name on it.
There's starting to be no room.
Yeah.
All right, so make sure you do this assignment.
Well, like,
Yeah.